Welcome to our webinar entitled Sustainable Crosswords. This session will be registered and we start immediately. Please, Maria Luisa, I start. We are researchers at Institute for the Study of Nanostructured Materials in Palermo, in the south of Italy. And this institute belongs to National Research Council of Italy, CNR. We will discuss in this time together, we will discover what is sustainable, which is the link between chemistry and sustainability, and finally, what can you can do for a sustainable world.
So in this first section, we will see what is sustainable. Sustainability means a lot of things. Please change.
Sorry.
It's a process in which there is an equilibrium among all parts. So he takes into consideration both the present and the future generation. It has to contribute to the Sustainable Development Goals. And above all, it has to increase benefit and have to limit the damage towards the society, environment, and economy. In a few words, sustainability is a way of life.
Discussion about sustainability measurement started already in 1998. At that time, it was evident that economy, environment, and society were strictly connected. And since a measurement involving economy couldn't avoid to influence, to have an effect in the other two fields of sustainability, which are society and environment. What can be considered as sustainable? Behaviors, processes, actions, thoughts, strategies, and also materials can be considered as sustainable. Some of these things are tangible. And for example, materials, it's something that you can keep in your hand. Other things of these slides are not tangible, but have a very strong consequence on the three fields of sustainability: economy, environment, and society. Let's think about a material. Material, why sustainable? How can be sustainable a material? If you produce these materials, create these materials through sustainable processes, and you use these materials for a sustainable world. In this case, is sustainable.
I think that most of you have already studied the 17 Sustainable Development Goals of Agenda 2030. All these goals have to contribute to the health of the planet, people, and environmental benefit, because only with these things there is a sustainable progress. In the next session, we see as our research activity and chemistry dissemination are involved in some of these goals, such as 7, for example. We will see how we can use materials for the clean energy, or 11, materials that can contribute to sustainable cities and communities. Moreover, clean water, materials that can sorry, absorb pollutants,
water.
Absorb pollutants for the water to make them clear. Or 12, responsible consumption and production. And finally, quality education, that is what I'm doing now.
Exactly.
All these goals are strictly correlated to those of the European mission. And in particular, our research is focused on healthy oceans, seas, coastal and inland waters, and climate neutral and smart cities. Please.
One of the definitions that we have seen of a sustainable action was an action that limits the damage and increases the benefit. This is a very important concept, and I will show you some examples. First, waste. Waste is the most critical issue of this era. I mean, we continue to produce waste and waste and waste, also due to the consumism that produce much more waste than in the past. The first thing that we can do for waste issue is reduction of waste. We should avoid producing waste. And the second is reuse. So we can reuse something that we have used for another function. We can find another life for this material. And then finally, we can recycle it. We can recycle in a new materials, compose it with other component, and create an entirely new materials that we use for, maybe it's better used for a sustainable world. In this sense, the 3 R's, reduction, reduce, reuse, and recycle, are very important for sustainability. Environment is suffering now. It's suffering, and I don't want to explain you why. Everybody knows it. But what is important is remediate environment. We should try to eliminate pollutants, degrade pollutants, for example, in water, in air, in soil, whatever. And then we should protect the environment and from further pollution. And what is also important, we should integrate environment with and should do a respectful exploitation of environment. Integration between human and technological activities and environment is very important. Efficiency. What is efficiency? If you have a process and you are efficient, this is sustainable for sure, because efficiency means high performance. Okay, this is simple, this is clear. Then you have less time, limited time for the production, for example, something, or limited costs and limited energy. This is a efficient process, and this is sustainable. This means that if you study more, if you investigate, if you research something about a process, you will increase the sustainability level of that process. Finally, if we need all the world, we need energy. We know we need energy for everything. But if we manage to produce clean and efficient energy or accumulate energy in batteries in an efficient way and clean way, this will be sustainable. Now we start the first crossword. Perfect. Now, Maria Luisa, it's your turn.
So, in this second section, we will talk about the link that there is between chemistry and sustainability. Please change.
Sì.
So it is well known that the conversion to the from the linear economy to the circular one is a priority for our and the next generation. And of course, also chemistry have to follow the same process. This is what we call circular chemistry. These are the 12 principles of circular chemistry, and in our research, as we will see in the following slide, we focus our research on the use, in particular on the use of waste, on the optimization of the processing that can enhance the efficiency by using no toxic reagents, solvents, and so on, focusing always our attention on sustainability. Please change. In order to make sustainable a chemical process, we have to use green solvents, for example, water or ethanol. Water is not always can be used because it cannot dissolve some organic materials. Ethanol can dissolve most of time both inorganic and organic materials. We can use energy-saving procedures. For example, in our research, I compared conventional heating with the microwaves. If a reaction in microwaves is the reaction with the microwaves are always faster. Faster means less energy, and less energy is an advantage for the environment. Of course, one of the aim of our research is the reduction of production steps, the use of waste as precursors, and the use of heterogeneous catalysis. Most of you have already studied what is a catalyst. Catalyst, I remember, is a substance that can increase the velocity and the selectivity of a chemical process. Normally we added in the reaction in a small amount. If this catalyst is in a heterogeneous form, for example, if the reaction is carried out in a liquid form and the catalyst in a solid form, it can be easier to be recovered and reused several times. In this way, there is an advantage for the environment. Please change. In our institute, we produce, we synthesize nanostructured materials and applied in the green chemistry and biomass valorization for the synthesis, for the production of biofuel and other valued products, or we can use these materials for the production of clean energy, as in the fuel cells. Sometimes, as we can see later, these materials were produced from waste as chemical precursors. It is very important in our research, the collaboration. Collaboration is fundamental. And as you can see in this slide, we can collaborate in Italy, for example, with the University of Torino and Palermo, but also in Europe with Spain, France, or Denmark. Or for example, with Canada or India, outside of Europe.
We belong to the Institute of Nanostructured Materials, but why these nanostructured materials are so important? Nanostructured materials have a peculiarity, have a very high surface to volume ratio, because they are. For example, think about intestinal villi. Okay, you have never seen intestinal villi, maybe, but anyway, that is a picture of intestinal villi. And these intestinal villi are very small, of nanometric size, and we will see also that the shape they are, this elongated shape is also very important, and they allow absorption of surface nutrients from the intestine 600 times more than if they were not present. So if intestine was simply without this villi. And also the gecko gecko legs have suckers that with similar shapes, similar size of this villi, and they allow to attach to almost any surface. The shape is also important, not only the dimension. So the eye surface to volume ratio is also for the shape, because if you look at the picture on the left, you will notice that the surface area, this is surface area, and this is volume. Surface area of, for example, this geometric object is much higher than spherical object, because you have angles and surfaces, and surface increase, and so surface area of the total object increases. What's happened if surface area increase? You have a larger interaction of the material with what is outside the materials, and if we are interested to, for example, degrade some pollutants or destroy some molecules, if these molecules are attached very numerous, a lot of molecules are attached in this material to these materials, so the materials will be more reactive. So nanostructured materials are more reactive, and if we try to prepare them in a particular shape, we will obtain even larger surface area and reactivity. How we prepare nanostructured material? We prepare nanostructured material through chemical synthesis. Chemical synthesis is simply a process that starts from one or more molecules and transform and combine them in larger molecules, in any case, different molecules. So it's a transformation of molecules. Molecules are together to form materials. This is the relation between materials and molecules, of course. But where do we take these molecules, the starting molecules? The starting molecules, we can buy them. For example, reagents can be bought from industry, chemical industry, and this is what we usually do, but we can do better and take the molecule from the waste. So we take the waste and we get the molecule and we use it. We don't need to buy it. So this is sustainable. And for example, we have organic and also inorganic. Inorganic means that it's not alive, let's say. So inorganic is silicon, aluminum, carbon, a sort of carbon, graphite, for example, calcium, copper, iron. These are elements, inorganic elements, and all the waste that you see there can be used as metal precursors. Metal precursors. It means that if you want a final product that has, for example, iron and also copper, you should use metal precursor with iron and copper. So you can use a waste with iron and a waste with copper. You put together, use chemical synthesis, and you will get the final materials with copper and iron. In this case, waste becomes secondary raw materials because they are reused for another synthesis, to prepare another material. And which kind of materials we prepare? We prepare materials for water pollution control, for production of biofuels, for materials for fuel cells and batteries.
Here there are some examples. I don't know how many people remember the film Back to the Future, in which the guy put the garbage as gasoline in his car. We actually, in our labs, we produced biofuels from waste, and such as waste fried oils, or also cellulose. They are the third generation of biofuels. They are biodiesel and biofuels and these additives, and they are actually used, as you can see, both by the plane as KLM, or in any station. When you go with your parents to go gasoline, you can see that diesel is added with 7% of biodiesel. Please change.
Change.
The other example is the use of green waste. We have treated, such as the compost, we have treated and extract some molecules. We make them heterogeneous materials, and we tested for the absorption of heavy metals from the wastewater treatment, or for the abatement of organic pollutants. As you have seen from the slide, all these research are in collaboration. And this is in particular with Torino, the other with Spain.
Another very nice collaboration project is an European project, which is Nanotech ABA. This started in September and is in collaboration with all these countries, so Israel, Denmark, and Portugal. We are here, me and Maria Luisa, and this is nice because we are working with the circular economy solution. So we want to clean wastewater with an integrated system, and this integrated system concern the first filtration ultra nanofiltration, abatement of bacteria, abatement of contaminant of emerging consorts, organic pollutants, and thermocatalytic nanopowder will serve to the scope. And this thermocatalytic nanopowder are exactly the powder that we prepared for this scope, and we can call them sustainable materials in the sense that we have seen before. This is a sustainable project for sure. Collaboration, as Maria Luisa said, is very important. We cannot do anything alone. Another project is with Canada, with Montreal, and in this case we try to produce clean and efficient energy through solid oxide fuel cell or metal air batteries. Solid oxide fuel cell or devices where chemical energy is transformed in heat and electrical energy, as you can see. So you produce a current, and where energy is not created but transformed, as you know, from physics, let's say. So where is this energy? Where was this energy before being heat or electrical energy? It was in the bonds of the molecules that are here, and chemistry plays a very important role in all these processes. All the processes are redox reactions. Redox reaction, which mean reduction and oxidation of elements, which means an exchange of electrons between oxidant and reducent and oxidant. Batteries accumulate energy, and then they release energy when we want to use it, like in our phone. So CNR, our institute, gives a contribute to some of the sustainable development goals and missions, especially to healthy oceans, seas, coastal and inland waters, and the climate neutral and smart cities, and all these 5 sustainable development goals. This is our way to reach sustainability and to go toward a sustainable world. And now the second crossword. And now the first very small part of our webinar, please, Maria Luisa.
In this section, we will see what you can do for a sustainable world. We have studied, and you have studied, the sustainable goals, no? And the mission of Horizon Europe. You have to think that they are not impossible to be reached, because as we have demonstrated, we are doing something about it. We are the researcher of today, and we will be the researcher of tomorrow. So you have to follow these missions. And but today you are students, and I think that you can do something in everyday life for sustainability. Please.
So I will give you some examples of sustainable action that you can do every day, that people does every day. For example, some people like to fight for environment through protests or working in international association like Greenpeace or some others, or some other people like to walking and riding bicycles instead of going by car for short distances, especially. Other people is sustainable because clean the environment when they notice that the environment is dirty. And also collaboration, as you can see, collaboration is very important for sustainability. If you collaborate, you will arrive, for sure you will reach the goal efficiently. Efficiency is higher. Maybe it's not so fast than alone, but is more efficient and is sustainable. And maybe you will have the impression to proceed slowly, but you will surely reach the aim in collaboration. And also respect. Respect for people, ideas, animals, nature, for everybody. This means to contribute to sustainable goals. So this is very important. Other examples of sustainable action are very simple. Everyday life. You have the mobile phones, and when something is broken, okay, I will throw it away. It's okay. Television is broken, I will throw it away. And it's not sustainable. You should take the television, the repair. There are a lot of shops now sustainable shops that repair things, because this is like in the past. In the past, it was a normal situation. So all the electronic devices, please first repair. If it's not possible, reuse. If it's not possible, recycle. So you should differentiate also. You don't have to throw it away in the normal garbage. And also, if you eat a food, if you don't finish your food today, you will eat tomorrow. I mean, don't throw it away, because it's important for sustainability, for respect for people, respect for environment, for what we have every day. And also, if you, it is better to take. It is sustainable if you buy some vegetables that are in your city, in your country, in your instead of import it, because you avoid transportation and energy costs, time costs of transportation, and so on. Then you have to reuse some object that you have at home. But what is most important for you students is that if you have some skills, you should improve them and then use them for society, economy, and environment. Please do not forget it. And any other action that you can do, you can invent, sustainable action, you can do in order to give an everyday contribute to missions and to sustainable development goals. The last very short